Good day, everyone. Welcome to C++ or CppChat. And before we get underway, I need to read today's disclaimer, which is we are not attorneys and cannot give legal advice. Joining us today are Robert Ramey. Good morning, Robert.
Hi.
And Bryce Adelstein-Lelbach. Good morning, Bryce. How are you guys?
Pretty good.
I'm just fine.
All right. So, are you guys excited about CppCon?
I'm very excited about CppCon.
So
so am I, and I'm actually working feverishly to prepare my presentations.
Oh, we're supposed to prepare those ahead of time?
That's what I do, but I know that it's not everybody's modus operandi.
So somebody on Twitter had said this thing about presenting, and he said, I always show up early and I check my check the audio levels and all these sorts of things. And I just and Kate had retweeted that, and I just replied and said, well, if I show up early, then I'm not waiting to the last minute to do my slides, am I? Which seems to be, I mean, I noticed there's an awful lot of people who are scheduled to present, and you don't see them before they present, and then you see them after they've presented. I'm assuming they're back in the hotel room feverishly putting together the last-minute slides, right?
Yeah, that didn't work for me, I have to say.
You have to have it down.
I have to have it down because it's already hard enough to make it coherent anyway. So that's for me.
I am one of those people. I shouldn't say that. Sometimes I'm one of those people. This time I'll probably have my stuff more prepared ahead of time. Probably I'll make my slides up next week.
Okay. Speaking of your talk, Robert, I'm highlighting one of your talks, which is the you have a couple of talks, but you have one specifically on proposals for what's it, SG 16? What is it? SG 16? SG 14?
SG6.
SG6.
SG16 is like the fake rockets.
Yeah. Okay. So 6 is numerics, right?
Correct.
And so you're sharing this with John McFarland, this talk.
You're correct.
Yeah. So talk to us about your proposal, the part you're going to be presenting. Well, first of all, tell us what he's going to present, and then we'll dig a little deeper on what you're presenting. So what is he presenting?
Well, he has a proposal for the Standards Committee for a fixed radix data type. A fixed radix data type would be useful for things like monetary amounts, dozens of eggs, and something with a whole and a fraction. Especially monetary amounts. There's nothing actually in the standard which would make us which would include something that is well suited to monetary amounts. And he's been working on this.
Dollars and cents kind of thing.
Dollars and cents. And this is, of course, naturally a very common application. And there's lots and lots of people have their own homebrew approaches to this. And I'm sure some of those, like big finance companies, have their own approaches which would probably be too considered heavy duty for homebrew. But anyway, it's a big topic, but it's very odd. I have to say that there's nothing ever been in the standard that addresses this.
Right. Well, we're not COBOL, so yeah.
Right, and well, some issues come up too with rounding, conversions, and stuff like that. So that is the thrust of his proposal.
Okay. Okay, so let's talk about your proposal.
Well, my proposal is basically safe integer. Safe integer is a drop-in replacement for built-in integers, and it differs from built-in integers in that it makes it impossible for one to write a program which will have undetected integer errors such as overflow, changes of sign, and things of this nature. In a nutshell, that's exactly what it does, and well, that's what it does.
Okay, so give us one example. Walk us through how we use it and what happens in that case. I mean, how does it detect this?
Well, what it does is at runtime, at compile time, and when a safe integer is involved in another integer operation, then it can, using the magic or whatever template metaprogram, it can determine ahead of time whether it's possible for that operation to overflow and or create some other problem. And if it does that, it will trap at compile time, and you'll get a compile time error. If it determines that it's possible for it to overflow, but it can't be determined at compile time, it will include code that will check the arguments before the calculation is actually done and throw an exception. And that's the long and the short of it.
So in other words, if I have an overflow, instead of getting undefined behavior, I have an exception, which is well defined.
Correct.
And
Correct.
is also, at least theoretically, something I could recover from in some way.
If you like.
So my question, the first question, because I'm a C++ programmer, is what's the performance penalty that I'm paying?
Well, it depends. For example, C++ automatically converts integer types through a relatively complicated algorithm to
I can confirm, yes.
yeah, and to standard to other types. But for example, if I add two characters or two 8-bit integers together, the C++ compiler will include code to convert those into 16-bit integers.
Well,
into addition.
Into int.
Into int, whatever that is. Yeah. Right. And so in that case, if we happen to know that the constituents of the addition operation are 8-bit unsigned integers, we know for a fact that the result will never overflow, will never change sign, so we don't have to introduce any code to check the result. However, if we turn around and if we use that in some subsequent calculation, well, that might be a problem. But the template code which handles this knows that the result cannot exceed the sum of 512. So it propagates those limits to the next operation, and so any arbitrary formula or expression may be possible to determine at compile time that will never overflow. And in that case, no extra code needs to be inserted. Now, if the final result is then turned around and then assigned to another 8-bit integer, at that point, code would have to be inserted in order to verify that it will actually fit in there. So the basic idea is that many times integer arithmetic can be known to never overflow, and in which case there's no checking required, and only those cases, only those situations where it's possible to overflow will actually code be injected.
Okay, so I understand. You can, with template magic, you can minimize the impact in all the situations because you can eliminate a lot of situations where.
Correct.
However, what?
It might also be an optimization, although your compiler might perform that implicitly. What's Robert saying is that there are cases in which it could improve performance potentially.
That's also possible, which is another issue besides, but I don't really dwelling on that.
Yeah. Okay. So, but my question still comes down to is that it might not be as expensive as someone initially thinks because it might not have to be in every case of every operation. However, there are operations where you're going to have to make this check and throw. And what I'm asking is, do we have any? I understand it depends on the nature of the application. Are we doing a lot of integer math or what? But do you have some feel? I mean, am I talking about I'm possibly giving up 1% of my performance, or am I giving up 20% of my performance? I mean.
This is of course a key question. It will depend on the app. I'm looking at the. I have to say honestly, I haven't really checked that, but it's my belief that it would be mostly undetectable in real applications.
Is that right?
Well, if it's a really heavy integer application and one has totally ignored the possibility, yeah, it might be an issue. But I'm thinking in terms of something like an ABS system or a medical instrument. These are not. I wouldn't. If I was, you're going to ask me to take a guess. I would say a 5% or a 2% performance hit.
Well, if it's
John,
heavily I/O driven, I understand that anything, you're talking a medical instrument, something that's I/O driven, I'm certain it's undetectable, right? I mean, because we're talking about integer comparisons here, right?
So John, the biggest impact would be if you are performing any of these operations in some context where they would be vectorized. If you were not using SafeInt, the possibility of the exception occurring would require masking. So it's very likely that switching from just regular ints to SafeInt in some contexts might disable vectorization, which could potentially hurt you, and not just loop vectorization. It could just hurt you in more broader contexts. I mean, if you have a highly integer math-bound code, you might use this as a debugging facility, though, in which case you wouldn't necessarily care.
Well, this would be an easy thing to do, but frankly, my real and somebody will conjure up a benchmark, will show that it slows things down. It's a practical matter. I don't think in most of the cases that I have in mind, basically code that has to be correct, it's going to make a heck of a lot or even a detectable difference. And should that happen, and should a profiler determine that the code in that particular bottleneck could be refactored slightly, for example, by using a long as an intermediate value or something like that, and the template metaprogramming will then not include the code for checking overflows, which is now no longer necessary. So I envision this being used as, okay, we just included in there to know for a fact that this thing is never going to fail. We run a profiler, whoops, okay, we got a thing here that's added 10%. We'll tweak that a little bit so it's not an issue. We're done. We ship it. We know it's correct, and we know that somebody's ABS system is not going to go into acceleration mode. That's the way I envision something like this being used.
And I agree with Robert, and I'm somebody who cares a whole lot about performance and very much does not like exceptions, and I endorse this idea. So I think. So
let me ask you a question, and I'm hoping maybe somebody in the chat room or somebody can answer this question, because it's kind of a survey question in a sense. Suppose someone wanted to test out a theory like Robert has. Robert has a library that everybody likes the plus side, but people are worried about the cost. So is there, what I'm asking is there something out on GitHub, some source where of a nice, interesting application, non-trivial application written in C++, where I could download that application, convert it over to using whatever my harebrained scheme is, and do some kind of benchmarking? Anybody have an idea of a library or an application like that? Something it's open source. It's not a library. It's a real application, so you could test it out in a kind of A/B way and say, well, I did this. Anybody have an idea of an app that would be like that? So
John, this is essentially a lot of what I do. My primary job description is writing and benchmarking code. I mean, I do a whole bunch of other things, but that's primarily what I do. And that's an interesting idea of sort of a catch-all benchmark.
Well, what I want is something that you could say real world, because clearly, if I'm writing my benchmark, I can either say, I really want to see what's worst case. In other words, I would, for this case, for Robert's example, I would write something that does a lot of integer manipulations in the inner loop and try to get worst case. But that's not really what I want here. I mean, I can figure out what worst case is. Worst case is completely unacceptable. But that's not the case that I'm really working at. Well, my question is, what's the real world impact? I realize that's an open question.
There's an entire field dedicated to this. So the answer is yes, there are benchmarks, but that's almost like asking, like, I'd like a better allocator. Is there a better allocator out there? Yes, there's a better allocator out there.
No, you've missed my question.
Okay.
My question was not, is there a benchmark? My question is there an interesting real-world app written in C++ that I could download and play with? That would that does a little bit of everything.
But I would suggest, if you just happen to have any app that you're sitting on your machine, and just for the fun of it, replace all the built-in integers with the safe version, and then build it and see what happens.
I don't have just any app that I have source to. I have
John,
tons of apps on my machine which I have no source to, right?
I think that's sort of universal, sort of across the board stress test would be very difficult to write. And more importantly, it would be if you could create such a thing, it would be really difficult to create it in such a way that that everything like that you could just like throw in SafeInt and it would affect performance. There tends to be some set of what I call sort of the dominant driving factors that drive the performance of a particular app, and it can often be hard to so like if your application is IO bound, and that's the dominant function, you might not see an effect from changing something to do with integer arithmetic because it's not the dominant the thing that we're spending most of our time waiting on, or the resource that's really the bottleneck. So because any application that's performance limited is bottlenecked at some point, anything that's not the bottleneck, you can change the performance of it and it may not have an impact that you can see. So it's very difficult to write that sort of universal benchmark.
I'd like to take this thing in a slightly different place. The issue of whether it hits performance, everybody raises that, but honestly speaking, I don't think it's going to be a big issue in lots of the kind of applications which I'm concerned about. I'm concerned about a whole different aspect. I submitted this proposal for presentation at CppCon 15, and it was rejected. I've submitted also to 4 other conferences on embedded systems, and it was rejected. I submitted it to this conference, CPP 16. It was rejected. I managed to get it snuck in by tailgating John McFarland's.
You were very effective in that.
Yeah, and the interesting thing was, I looked at the comments from reviewers, and the dominant idea of the comment is, what do we even need this for? What's the matter with the built-in integers? And that was actually the dominant sentiment. And if you go over to the CERT, the computer security website, and they talk about programming in C and C++ and how to make a secure program, first of all, they list all the problems that you can get into using the built-in C and C++ integers, and then they also prescribe how to address them, and their prescription means going through your program at every single point where an integer operation is specified, and insert code to verify, insert code in this with a special idiom such that it can no overflow will be undetected. This is a totally ridiculous proposal, but the interesting thing about it is nobody complains because people totally ignore the issue. Their view is that if I write a formula, it's going to work, and contemplating the possibility that it's not is not worth anybody's time. This to me is the huge elephant in the room. Now we're doing the F-35 fighter jet, we're doing the Tesla cars, we're doing medical instruments. We've got situations where $500 million rocket was lost because somebody overlooked this. And that's what I'm looking at as a problem. You can't write a formula and know that in fact we're going to get a correct arithmetic result. And then we're building huge cathedrals on this foundation, and nobody cares or is interested or wants to think about it. That's the interesting aspect to me about all this.
Well, it does.
I don't know if I went off. That was too much of a rant.
What it does bother me. In fact, I think about this. Suppose that someone asks you to do something really simple, like they ask you to write a function that will calculate an average. And so you're going to add up a bunch of things, and you're going to divide by the number of things. And you might be invoking undefined behavior there because the things you might be adding up, assuming it's a template, you don't know what you're adding. But even if you knew, oh, I'm adding up a bunch of integers, they're signed integers, if they overflow, it's undefined behavior.
You cannot look at code, a simple arithmetic formula, and know that it is going to produce the expected result. That's a problem in a nutshell for me with the whole computer programming in general and C++ in particular.
We've been conditioned to accept this as the norm because of C legacy, and like the fact that C programmers are like, well, why would we want this? We're used to dealing with all of this, craziness. That I think is indicative of how big the problem is. That people see something like this and they're not like, oh, that's great. They're like, we've adapted to this.
I'm Cassandra at the walls of Troy. I'm destined to see the future and know the future and see the problems that are coming, and yet I'm also destined to have no one listen to me. That's I don't know.
That was a very high class reference.
Thank you very much. Well, maybe that's my problem. That's why maybe nobody's listening.
Because I don't know who Cassandra is. I think that. I think part of the problem is, imagine doing a calculation where your long ints are going to overflow. There's kind of a, wow, could that, what are you counting where your long ints just overflowed? And then there's a sense in which if that happens, it's an.
No, you know what happens is they say, oh, that'll never happen.
Well, no. I think there's a more nihilistic approach, and that is. There's an analogy here to memory. It's a frustration about the way C++ works, which is that any allocation we assume can throw, and so we are in this situation. And Swift, by the way, has a different approach, and their attitude is, if you throw, that's not recoverable. Or I shouldn't say if you throw; they don't throw. If you run out of memory, if you cannot allocate memory, that's not a recoverable situation.
I think that should be the default policy. You should be able to write an allocator that can throw, but I think by the default allocator should be no throw. I agree with that.
The problem is if you're saying that it's possible for it to throw, then you have to write code assuming somebody's using an allocator that throws.
I'm saying it's condition. I'm saying it's like conditionally no accept, and then you can be conditionally no accept too. I think that the use case of wanting an allocator that throws when it runs out of memory is useful. I just don't think that it's the right default.
No. You either write code knowing that it could throw, or write code knowing it can't. You can't. You
can't have both ways.
You've just made it the worst possible situation where you can have you've written all this code because it has to be, you don't know if the allocator is going to throw or not, so you have to write all the code so the allocator can throw, and then you end up having an allocator that doesn't throw, and instead you have therefore you have no opportunity to recover. That's the worst of all possible worlds. And the problem is with the Swift approach is that you've left behind 0.0001% of your applications. There are embedded systems and other systems that actually do expect to be able to run out of memory and recover. And the only way that can be done is if you throw, and that's why we do it in C++, because of that possibility.
Hang on. What I'm saying is that like operator new should be no accept and should not throw. The default new stud allocator should be no accept, but you should be able to write an allocator class that is not no accept, and then people can use that, and people should write code.
But you understand what you've just said now. That means that if I'm writing a library that I think somebody might want to use a throwing allocator, I have to anticipate that they could throw.
Yeah,
that's what I'm saying. It's insane.
Okay, but that's tough luck, because I think that there's a great benefit to the default behavior being no accept, which is that like 90% of the standard library could be no accept. But I think that the use case of wanting to write an allocator that can throw is valid. I just don't think it should be the default, and I also think that it's
Bryce,
something that
you're missing my point, which is fine, go write your allocator, but you can't use it with real-world software because no one's going to write software anticipating an allocator throws in your scenario. So it is, unless you're going to write unless you're going to write all your own application, unless all the code is yours, because that's the only situation where you're going to have code that anticipates an allocator throwing. And that's the Swift world, by the way. What Swift has decided is that running out of memory is unrecoverable, and therefore they can just write code based on that theory. And the thing is, almost all, if you're using a Unix machine, if you're in the Linux world, certainly, I believe this is generally true in the Unix world, certainly it's now true in all iOS, that you cannot recover from running out.
Hang on, I strongly disagree with that comment. So there are new memory technologies that are currently coming to market, high bandwidth memory technologies, so like HBM and HMC, which offer basically some form of high bandwidth or high throughput memory that will be distinct from DRAM. That's starting to be available as a separate pool of memory on your system. If you might run out of, you might have a special malloc on your system that gives you faster memory. You could run out of that, and then you could still have a pool of DRAM. Or what if you have a stack? What if you have you want to write a stack allocator, and you've given your stack allocator some buffer and it runs out of buffer space. So I think there are valid cases for wanting to have an allocator that throws. As much as I would like to buy into your argument, because I really hate the fact that
it's not my argument. It's the observation that Apple has made, which they are never. You can know because they bought into Swift that no operating system on the Mac is ever going to have a recoverable memory allocation error. Because their apps won't be able to handle it.
But I think you're talking about the default system allocator versus some other allocator.
Okay, but I understand what you're saying is, oh, well, we're going to have some allocators throw and some don't, and we pick the allocator we want. And I'm saying that's ludicrous because software has to be written with assumption about the underlying allocator. The assumption is either going to be that it throws or that it doesn't. And and you don't want to write software that's assuming the allocator throws, and then 99.9% of the time it can't, because, I mean, that's just, nobody's going to write that. They're going to say, well, look, let's just assume it doesn't throw, because that's what the standard does. And if you want to use this other allocator, then don't use our library.
Okay, look, I agree with you, or I agree with that point of view, but there are people that make the argument, I think taking that stance is not the correct way.
Wait a minute. I haven't even taken a stance. I just explained to you what Swift is doing. And I've let you know that in their world, because they bought that argument, that's their world. I've never said that C++ should be like this. You are the one who said that you think the default allocator should be that way. And I think that's insane.
I'm trying to explain to you why I'm not claiming that you're making that argument. I'm trying to explain to you why I, a person who does want to change this behavior, why I'm not making that argument. And part of the reason is because I don't think that would succeed. I think there would be enough people who would have use cases that would be valid, that you would not be successful if you were not able to support that.
Well, that's one of the reasons. That's why I said. And I don't think C++ should change, because there is that 0.001% of the world that lives in a world where they want to be able to recover from memory errors.
But okay, so the fact that new in my opinion, exceptions are one of the few abstractions in C++ that's not as zero cost as it should be, in a very infectious way. So, like, while I admit there might be valid use cases, like there are performance costs associated with the exceptions that I have to pay for. Like I have to pay for the possibility of a whole bunch of stuff throwing because it could throw bad alloc. And like a whole bunch of stuff, meaning that I can't use it in a loop that I'm vectorizing because it might throw bad alloc, and like that's a whole bunch of costs that I'm paying that I shouldn't have to pay because
you're vectorizing stuff that could throw. That's really weird. I mean, you're vectorizing stuff that could allocate.
Okay. So the canonical example is like, let's say you wanted to allocate memory inside of a loop that you're vectorizing. Like you can make a call to a function that's not a vectorized function within a vector context, and the compiler can sort of generate the serialized calls, but not if there's a possibility of thread divergence because of an exception might happen. So like if you're calling some opaque, if you're calling some opaque foreign function in a vector, in a loop that you're vectorizing, if that opaque foreign function is no accept, you're good. But if it's not no accept, then you have to serialize. And that sucks.
So the reason we went down this path anyway is I was using it as an analogy. I was just saying that there are people who say running out of memory it's not that it can't happen. It's that if it happens, you're hosed anyway. And that tying this back to integers, what I was saying is that there are people whose attitude is it's not that we could never overflow integers. It's that if we overflow integers, we're already screwed. We're already in a world where how do we recover from that? Because I'm trying to process so much data that I don't even want to think through how I'm going to, if I need to add these two numbers together and they're greater than I can hold in my long, then I don't know. I don't want to think through all those scenarios.
My problem with that is one thing, that the current system, you don't even detect it. You blindly keep going on, and it goes on until your program blows up in some totally different place, or it returns the result gets truncated. You get an incorrect result, which looks correct, and the program continues on. You have a bug buried in there which is undetected and frankly undetectable with the current scheme of things.
Right.
It's not so much that I'm hoping that people will recover it from it. I'm hoping that will actually be detected so that people will be able to decide what to do with it. Right now, it's just, we're under the gun, we're late, they're under pressure, we can't think about this now, and by the way, it's never going to happen. And if it does happen, I won't be working here anymore. And if it does happen, we got other problems besides. Hey, it's just not a priority. And my view is that if you can't expect the program, read the code and see what it's going to do, we're on the wrong, we're right away, our premise is wrong. That's a different way of looking at the world.
Look, I agree. In both cases, there's UB, but and UB is UB, but some UB is worse than other UB. I think
that's the wrong attitude.
See, that's to me, and I agree that's the wrong attitude, because the fact is, at that point, instead of saying we're going to prohibit any behavior which doesn't make sense, then you're going to start picking through on a case-by-case basis. And at that point, you're looking at a piece of code, well, will it work or will it not work? Well, it probably works. It's good enough. And there's just no standard anymore. You're not even clear what the heck we're calculating or what we expect the program to do. That's my concern here. It's the attitude problem I'm concerned about, and that's where I stand.
So as soon as I knew before I said that you guys were going to slam me for that. I was. And you
deserved it too. You were asking for it. You're a glutton for punishment.
But no, I really I think what Robert's trying to do here is very important. I mean, all of us have written these sorts of integer related errors. We've all done it, and it's probably been one of those bugs that's bit you in the ass in a really unpleasant way at some point. This sort of facility is something that would be really nice to have.
What's striking to me is I was looking at some other YouTube video about a guy talking about JavaScript. JavaScript is a language. It's got its, whatever. But the interesting thing that he said is, oh, by the way, if you could make this kind of mistake, it won't be detected. And there's no language in current use which will detect this kind of error. And as far as I know, that's a true statement. You can make the same mistakes in Python. You can make the same mistake in Visual Basic. I don't know. This is a pervasive view that we're using a computer and to do some calculation, and it sort of models the mathematical world, except when it doesn't. But most of the time, it's okay. But for the applications we're starting to make now, I don't think that's good enough anymore.
Yeah.
And C++ has a unique ability through operator overloading and all this to actually fix this problem in a real way, even an efficient way. That's what I'm saying.
Without having to redesign the library or the language.
Yeah.
Without having to redesign the language because of templates, because of operator.
Right, which you can't do in any other language.
Yeah.
It's a unique ability to extend the language in a practical and efficient way and to address a real problem that nobody believes is important. I think the real bottleneck here is the last sentence, that nobody believes it's important. I think that's wrong, and that's what I would like to see corrected.
Yeah, I certainly agree. In my industry, most of the time it's okay when used in the context of numerics is not an acceptable answer. So
isn't your industry like got something to do with A-bombs or something? I mean,
I am currently chatting from a former Manhattan Project.
Okay,
site, so
I think that's the case, and here I'm thinking, sitting here in A-bomb simulations or who the heck knows what, and we're doing a relatively simple arithmetic calculation, and we don't really know. We can't really prove that we're never going to have an undetected error. I mean, to me, that kind of sums it up in a nutshell.
Yeah.
It just goes to show how out of touch I am. I'm proud to be old. I worry about this stuff, and I feel like I'm all alone out here.
So one of the questions I'll ask an application team when I start working with them to optimize their code is, if I can make your code 2 times faster, but the cost is that there's a 0.0000001% chance that there will be errors, and those errors will lead to silent corruption, and we'll never be able to come up with a way to detect them. Is that okay? And the answer is almost never no. It's almost never yes.
So let me ask you
I kind of lost the thread of the question, but anyway, my question is it acceptable to, in your context, to make a program which will generate a wrong answer without letting us know?
The answer is almost always no, that you can't do that.
Okay, I rest my case.
So are you seeing the links in the chat room, Robert? Somebody is pointing you at things you likely have seen before, but
I'm not seeing any links here. I think
in the chat room, in the IRC.
Oh, I don't have that up.
I posted it to the
So
here.
They're mentioning John Reigeher, or does anybody know how to say his name? Reigeher. Okay, I think he's. Is he out of someplace in Colorado, something like that? I don't know why I think that, but I think that. Anyway, what would you guys think about having him come be a keynote at CppCon maybe next year or something?
I don't know who he is. So many.
He's the guy who's been raising the flag about integer overflows and bizarre integer. Professor of computer science in Utah. I wasn't that far off.
Well, I hope he has more luck in getting his presentation accepted than I have.
well. So Robert, the people who decide keynotes, 2 of them are currently in this hangout. So.
Well, and so you guys have rejected it twice.
Hey. Look, when we accept it, it's because it's our fault. But when we reject it, it's not our fault. It was somebody else.
Yeah, I'm sure. But anyway, I think, as I say, to me, the issues in the topic are fairly well defined. They're extensively described at the CERT website, and they're typically often associated with hacking, with errors, with things. So it's not the issues that are a problem, it's the mentality of the normal programmer. That's the problem.
Yeah. MTT in the chat room says that he's written the resource on undefined behavior. I think he means undefined integer behavior, but
I think he may have been. I think that this is a name that has been floated to me before as somebody to consider, but I think it might have been in the context of that crazy UB guy. Sometimes people will pitch ideas about the conference, but it'll be 2 a.m. and then I'll go look at my notes the next day and I'll have a note keynote, that crazy UB guy, and I'll have no idea what it means.
Well, I have to say, I don't have the chat thing here, but if there is such a person, I would be very, very much interested if you were to look at the Safe Numeric page and the comment on the documentation at in the Boost Library Incubator. So, because I'm interested in feedback on this, I spent a lot of time at it, and I'm thinking that could use the scrutiny of somebody who has also invested a lot of effort in it. So I would invite that gentleman to Google safe numerics, and then they'll find the page, and any comment he wants to make, I would be pleased to receive.
So I'm gonna ask you, Robert, a tricky and unfair question. Typically, in the past, and this is a bike shed question too, so it's gonna be really good. In the past, the Standards Committee has tended to explicitly avoid using safe in identifiers with sort of the thing like one of the names suggested for this joining thread construct, which would be a thread that joins in its a stood thread that joins in its constructor, was to call it like safe thread or something like that. And typically the argument's been you shouldn't call something safe because then everybody will use it because why wouldn't you want the safe version? And people might not understand that something that's called safe might be called that because there's some penalty for the safety, and then
that's one of those situations where the Standards Committee is just crap.
Right. But I just wanted to get Robert's.
In fact, if I see something that's called safe, I immediately say, "What's that going to cost me?" I want the safe alternative, but I want to know what it's going to cost.
I'm just telling you that.
Because I'm assuming nobody builds the non.
It's kind of like safe sex, It just takes the edge off. Huh?
So Robert, what's your thought on that? Do you
I don't. Frankly, I'm not a big. Reason I use safe is because it was really inspired by David LeBlanc's Safe Integer Library, and I thought it was a good name. I don't really care about that. The Standards Committee, the idea that something like this is interesting for. I've submitted to the Standards Committee, but of late I've really kind of been losing interest in championing it in the way that I was before. I made a slimmed down version for the standard. The real heavy duty version with policies and all of that is been proposed for Boost. I'm thinking that once a library surpasses a certain level of ambition and scope, that it's not really a good candidate for the C++ standard library anymore. We've got Eric Niebler's range library. I look at that. I think it's a fantastic work, but I just see that and it includes its own implementation of concepts, its own replacement for MPL. It's just, in my view, too large to be handled as a standard library component. We need another place for that. I have an idea for that, but I think that the whole, and I've listened in on the standard meetings. There's a lot of bike shedding, and everybody. It's frankly agony to attend. And so I think that the idea of making the standard library ever larger is something that we should rethink. So there we go. That's a whole nother topic. And the issue of whether it's safe or not. If somebody once said, "Oh, we would accept it, but change it to George," I would say fine. But that's not, frankly, of interest to me, really.
So one of the most important things I've learned since joining the Standards Committee is if you have zero attachment to what something's named, you are much more likely to be successful, because changing a name of something can often change somebody from being against it to being for it. But with regards to your comment about library size, I do agree, and I feel that there are certain libraries, like Spirit, for example, that would never be really good candidates for standardization, even though they might be something that's sort of mature and a good idea. But
bringing this up earlier, Robert, and I think you've missed the point, Bryce. There, he's not saying that there are some libraries, because Spirit is kind of a narrow-focused library. It's not for general use, but ASIO is for general use. And what Robert made this point, and it kind of blew me away when he made it, which is what wonderful things about CppChat in general is to have these kinds of ideas and discussions, because it had never occurred to me before. I kind of had this idea historically that when a library gets, well used, let's make it part of the standard. And what Robert is saying in the example of ASIO is, does it really make sense to have 3 different versions of this library? Because that's what's going to happen, right? I would really hope that none of the compiler teams are going to decide they're going to write ASIO from scratch if it gets accepted in the standard. And so
I think you'd be wrong on that.
you think somebody's going to rewrite Osseo from scratch?
I again, I think you'd be wrong on that.
Wow, that
Tell
blew me away.
What
about the serialization library?
Is Marshall going to do that? Is Microsoft going to hire somebody to go out and write
standard libraries are written in a very particular way. They're used by they have huge user bases and very particular needs. And I think historically there's also licensing issues for that matter.
Well, not for anything.
I'll give you an example, John. We added the special math functions have been added to the C++ 17 standard. There's implementations of them in Boost. Marshall Clowes, every time he's giving me a hard time because the special math functions get used up in my users. So he's like, you've created all this work for me, and so you might wonder, well, why wouldn't Marshall just go and import the Boost special math functions into libc++? Like that would be the natural approach. And he's thinking about that. But the important thing is he's thinking about it. Marshall's got a difficult task that
the math functions, as difficult as they are, the real challenge there is testing them. It's not implementing them. Osseo is a different beast.
But the point is that
not thinking, should I take a couple of weeks and rewrite Osseo?
My point is that I know standard library maintainers who just importing in somebody else's code as the way of implementing your functionality is not necessarily going to be the best choice. I don't speak for Marshall. I don't know that's necessarily going to be the case.
Okay. Rewriting Osseo is man years worth of work that cannot be delegated to people just out of college. It's a waste of, speaking as the entire industry, it's a waste of our resources for them to do that. It makes a lot more sense for them to push their changes into a common version. I'm not saying they'll do that. I'm just saying it makes more sense.
I guess my real point is that standardizing a library like file system or Osseo, I don't think we should necessarily assume that means that we're going to standardize the library. We're standardizing the specification of the library.
Oh, I understand that. But what I'm saying is that having them rewrite something of that scope from scratch, it's just a waste. As an industry, it's a waste of our resources. I wouldn't want them to do that. Think about the things that Marshall could be doing.
Look, we should get Jonathan Wakely on here to talk about the networking TS at some point, anyways.
Okay.
I think it's an under-discussed topic.
You've spoken to him. Write to him. Send him an invite. Tell him we want him on, and tell him that in England it's not at 9:30 in the morning.
Or you know what? I'm not sure if the time zones works, but Chris Kolohoff's somebody that would be great to talk about this.
We'd have to be in the evening for that.
Which I'm fine with.
For this particular argument, Wakely's point of view is more important than Chris's. But anyway, what we should do actually is we need to wind down because we've burned through all this time. You know, somehow I kind of knew that having you and Robert and me on the same time, we were not going to have difficulty thinking of things to say. So we don't have a lot of time now. I do want to mention CppCast. CppCast is back, and this week they did something a little bit differently because they did not have a guest on. Normally, you guys both know this, they have a guest on and they interview the guest. They usually have a couple of news items they talk about before the guest, which is kind of our turf. And this week's CppCast, all they did was news items. Interestingly enough, they did a better job of covering the week's news items than we did. So I think that's pretty bad. But I do encourage people to listen to CppCast. I will say this because my head is thinking about the conference. If you can possibly make it to CppCon, we're gonna have a lot of fun.
We're gonna have a ton of people too.
Yes, we're gonna.
How many people are expected to?
I'm running the numbers right now. Actually,
we should be able. We should be at 900. We may not.
I think
we will.
I think we're pretty close right now. Let me see what the current count.
Well, we're not at 900 now, and that's a 10.
I have 821.
Yeah.
Assuming all the speakers register and all the volunteers register.
No, we're ahead of that if you make those assumptions. No, we're at like 885 with those assumptions. We're really close to 900 with those assumptions.
Okay.
And
we'll have a boatload of people.
Yeah. We'll probably touch 900.
Yeah.
And you got 3 weeks. I'm sure some people will decide at the last minute. So.
Yeah.
Oh yeah. But we have already more paid registrations. In fact, for a week now, we've had more paid registrations than we had in previous years.
Yeah.
Well, in fact, what I was going to say is we have more paid regular registrations. If you look at just total registrations, because we had so many early birds that it's been a long time that we actually beat previous year's paid registrations. So yeah, we're going to have a ton of fun. We're going to have more exhibitors, so there's more things to talk about. It's going to be great. It's going to be a lot of fun, and that's where my head's at. In fact, I'm finished with all my training requirements now, so I won't be doing any training between now and the conference. Basically, for me, between now and the conference, it's only conference. I'm going to be working on the conference full time. There's so many things to do,
as will I, despite the fact that I actually have the job too. But
that's one of the things I need to talk to you about, Bryce. We got lots of things that we need to do to get registration ready, all those kinds of things. Let's see, what else is going on that we want to talk about?
And just for those who are interested, we should have the plenary schedule and the panels up in the next day or so. I've had a paper submission deadline at work, so that's been a little bit delayed. My apologies for that, but I should be able to do that.
So can we tell people what the panels are going to be?
Everybody
I assume knows what Monday night's panel is going to be.
So there's going to be a grill the committee panel.
Grill the committee, we do that
on Monday. I don't know who all that's going to be, but we'll have that up. And then on the closing panel is going to be a panel of standard library maintainers and some people from the library working group of the standards committee. We're going to talk about this possibility of a STUD 2. So we reserved namespaces for future standardization at the last committee meeting, and there's been this idea that we might have a chance to design a new standard library interface that will incorporate things like concepts and ranges. And something like a standard library, you don't often have a chance to make breaking changes to it. So there's a whole wide range of possible things we could do if we were to create a new standard library, a new range and concept-based standard.
Like we could fix Max, for example.
There's much better things to fix, like locales, IOStream. Trust me, there's a whole bunch of fun stuff that we can fix. Exceptions. So that's what we'll talk about there, and we have a great panel lined up for that.
All right. So I guess until next weekend, I'll say safe coding.
Safe coding.
All right.
Okay.
Been great having you guys.
I've been here the whole time.
Goodbye, all.
Okay.